Alright, hello, my name is Jim Pingle and welcome to our pfSense Hangout for March 2016. This month we'll be talking about Multi WAN on pfSense 2.3. Short overview of what we're going to be talking about today. We've got some project news to talk about. We'll talk about what Multi WAN is, why you'd want to use it, how it's improved in 2.3. We'll go over failover and load balancing and what the differences are. How to choose service providers for your additional WANs. We'll go all the way through an example setup. We'll talk about some tweaks that you can do to change the behavior of multi-WAN. Then we'll talk about how to test and troubleshoot, and should have some time for a little bit of Q&A at the end. All right, first up, for some project news, we're going to have a 2.3 release candidate any moment now. Probably not today, but probably early next week. We're trying to time our release roughly parallel to FreeBSD 10.3 release, which is happening as we speak. There are snapshots up at snapshots.pfsense.org. Since last month, you might not have noticed if you're not running the snapshots, we have our new RRD graph interface in place under status monitoring, which replaces the old RRD graph view. You can get to all the same data and everything. It's just a lot more modern interface, a lot easier to contrast and compare things and customize graphs. Also, we have an inline IPS mode using NetMap with Shirikata 3.0 that's available now in our packages. Just beware though, at least with certain NICs, if you do activate that inline IPS mode with NetMap, you might have some trouble with traffic shaping, but people are really excited about that. About the NetMap interface. It actually goes truly inline. It can block things without having to see the first packet flowing all the way through, which is a lot more secure. So it's a big win there. And if you're not already running 2.3, now is a perfect time to start, especially when we get the RC builds out. We don't expect to have any changes at all, if anything, between release candidate and release. So we may just roll right to release unless there's a big showstopper that pops up. So if you want to get feedback in, now's the time to do it. See the XG2758 unit that we talked about last month, that's a replacement for our C2758. That unit is now shipping. So they're already making it into customers' hands. We've seen a few people have them already. We have our European pfSense training coming up in a month, or a couple weeks actually, April 7th or 8th in Bournemouth in UK, April 12th, 13th in London, and May 17th to 18th in Frankfurt, Germany. All those times are 9 a.m. to 6 p.m. local time. I think there's still some spots open in all of them. So if you're interested and you're going to be in the area, just go to netgate.com/training and get signed up. The folks over at Serve the Home did a review about 6 months ago of an SG4860, and they posted a follow-up review with some thoughts after using it for a while. It's a really good review, so if you want to hop over there and check that review out, and it's a really good read. And also, as our release candidate builds happen, and then we have some other news going on, just keep an eye on the blog. We'll have some stuff that should be showing up there in the very near future. Okay, first up, some of you may already be familiar with Multi-WAN, having used it on previous versions. And in 2.3, there are some pretty good differences here. We've replaced the A-Pinger utility that we used to have to monitor gateways with the D-Pinger utility. It was a rewrite from one of the community members with some of our work chipped in. The new utility is a lot more robust. Sane, I want to say, a lot less problematic than the older A-Pinger utility. For instance, it has a lot more fine-tunable control over how it averages. It doesn't have any of the problems that A-Pinger had with throwing things out or coming back up too early. I'll touch on a few of these things as we go through. Our default gateway switching feature has been improved. Before, if you had like a PPPoE WAN as your primary and it went down, the default gateway switching would not handle that scenario well at all. But we have fixed that up, so it should work a lot better. There are still some instances where the default gateway switching is not ideal, especially if you have a lot of or local gateways that lead to places that are not the internet. Depending on the order of the gateways, the switching algorithm is not as smart as it could be in picking the gateway. So we're hoping to improve that again in the future. I don't know if that'll be in like a 2.3.1 or the 2.4 release, but we'll have some improvement happening there over time, either a way to mark a gateway as eligible to be default, or maybe a default gateway group type thing. But that's coming in the future. But for now, for a lot larger group of people, default gateway switching is available, and it works for them a lot better than it used to. We've also done a lot of cleanup to gateway handling. One thing you might notice is if you had, for example, a Hurricane Electric tunnel for IPv6 tunneling, it used to make like a dummy gateway for IPv4 that would show up, and it didn't do anything. There wasn't a purpose to it. So we've cleaned that up, and those types of things won't show. They still will for OpenVPN because it's a little bit harder case to handle, but it's a lot cleaner overall. When it comes to weighting, we'll talk about this when we get to load balancing, but you can weight gateways for uneven balancing, and the weight limit used to only go up to 5. We've increased that to 30 thanks to some parsing improvements in PF. We're able to make that a lot larger. And also the RFC 2136 dynamic DNS, which is a different dynamic DNS protocol that's used directly to name servers rather than using like a web call or like a web API type thing with HTTP or HTTPS like the other DNS clients do. That support has been there, but it didn't support multi WAN, and now that supports multi WAN. So what is multi-WAN? If you don't know, it just means multiple WAN connections on a single firewall. It could be multiple internet providers, or it could be just multiple circuits, or just any time you have more than one potential path out to the internet, we consider that a multi-WAN scenario. So it can be any interface, any type of interface. There's no restrictions on that. It could be something that has a couple of hops before it gets to an internet connection, as long as you can send traffic out that way, and that traffic will eventually get to the internet, properly and comes back. You can consider it a WAN type gateway. So it could be a direct ISP connection. It could be an MPLS to a remote site that has a internet connection down the line somewhere. It could be a VPN provider of some sort. So there's no restrictions on that. They could be, you could have 5 PPPoE WANs or static or DHCP, whatever. We don't really have a theoretical limit to how many WANs you can have either. We've seen some pretty crazy scenarios with a bunch of different WANs. There might be some practical limits because you can only have 5 different tiers with failover, but in terms of balancing, you're pretty easy to bundle a bunch of WANs together. And this works out really well for SOHO type environments and even some larger businesses. If you're not big enough to get an IP block of your own to do BGP, or you can't get any internet connections where your provider will do BGP with you, you can use multi-WAN to still get failover redundancy or increased bandwidth through balancing. And all of this does work fine with a high availability cluster. But when you do that, all of your nodes need access to all WANs. I know some people are really tempted to try and do an HA setup where you have two boxes and WAN 1 is on one box and WAN 2 is on the other box. That doesn't work. Both nodes have to have a connection to WAN 1 and WAN 2, so you need to take that into consideration when you're searching for providers and what they'll support. So like, for example, you need to have like a 29 block on each WAN, and then each node is on both WANs, and you do carp on the WANs, just like you would in a single WAN scenario, just with multiple WANs like that. So it all works. You just need to meet all the requirements for it. So why would you use multi-WAN? There's a few different reasons. Main reason a lot of people use it is redundancy, or for WAN failover. For what that means is on the inside, like for your local devices or clients, it means you can always get out to the internet as long as one of your WANs is up. If you've got a preferred WAN, you could fail over to a secondary WAN, but it just means you're not completely out of commission should your WAN go down. For inbound access, like locally hosted services, especially things like a PBX or a local web server, mail server, that kind of stuff, every WAN that you have can accept inbound connections for local services. I know that's kind of a tricky point with, there are some equipment where that doesn't quite work, like you can only have one WAN active at a time. But in this case, because PF has what we call a reply to keyword, packets that come in WAN 2 and go through are going to reply back, and PF is smart enough to know that that came in WAN 2, it's got to go back out WAN 2. So those port forwards or things like that can be active on all WANs at all the time. So if you have something like dynamic DNS that can switch from one to the other, coupled with like a low time to live on the DNS records, you can fail over services on the inbound path as well. Where things like mail servers, you could have one WAN as your primary MX and secondary WAN as your secondary MX, and mail servers will figure that out too. And some services on the firewall, like VPNs, like OpenVPN and IPsec, they can be made to switch from one WAN to another as well, giving you extra redundancy for your VPNs. Another big selling point of multi-WAN is for additional bandwidth through load balancing. So if you are, say, in sort of a remote area, or you've got a remote office that's in a little bit of a remote area, they may not be able to get a high-speed circuit like if they were in a bigger area. So you might be able to get multiple slower circuits rather than one larger circuit. But in most cases, though, unless you have a provider that supports multi-link PPP, you can't get true aggregation. What it does is connection-based load balancing. So if your client opens up a browser, that connection might go out WAN 1, might go out WAN 2 if you're using load balancing. The browser opens multiple connections, it might use both WANs at once, but no one single connection is going to be able to exceed the bandwidth of one of your WANs. However, if you have a program like a download manager, torrent, whatever, that's going to utilize multiple connections, it can effectively fill them both up, but it's by using multiple connections, not a single connection. And using weights on the gateways, you can do uneven balancing. Like say you've got one WAN that's 5 meg and one WAN that's 10 meg, you could weight them, with a 2-to-1 ratio, or if it's like 3 meg and 10 meg, you could do like a 3-to-10 ratio. However the math works out, you can pull off those ratios using weights pretty easily. The only thing, our weights now go up to 30, like I mentioned a little bit ago. So you could do up to a 30-to-1 imbalance, which would be a pretty big imbalance, but it still happens in cases when you might have like a 100 meg WAN or a 3 meg WAN or something. So there are some devices out there that claim to do true aggregation across multiple WANs, but although it's tempting to look at them, sometimes they can add extra latency and overhead in doing so, because they tend to funnel all that traffic inside of what is essentially a VPN back to their data center, and then all of your traffic goes in there, funnels through, flows back out, but you have that extra latency because it has to go across the internet to their office, then from their office out. You also have the extra overhead from the protocol, so your packets can't be as large. So between those two, you might get higher overall throughput, but some things you have might suffer because of the extra latency or loss of packet size. So just be wary of things like that if the ideas get tossed around if you're considering whether to use pfSense or something else for multi-WAN. So another reason you might want to use multi-WAN is for service or bandwidth segregation. You might have a priority service like VoIP that you want to always have access to one circuit. So you might have, whether it's like a T1 or some other kind of dedicated circuit just for VoIP. And then you might have, say, a cable line for your regular browsing. You could have them do failover, where if one goes down, they use the other. But for most of the time, you could have the VoIP prefer to go out the dedicated circuit, and your web browsing prefer to go out the other circuit, and that isolates their traffic so that one can't interfere with the other unless your circuit fails. And that kind of isolation is good because you could try to assure that the traffic is going to go with traffic shaping, but traffic shaping isn't always perfect, especially when you have a lot of inbound traffic and maybe the upstream is kind of flooding you a bit. So it's really good to have that option to do segregation if you want it. And it can also do lower priority traffic in that way too. Say you've got your regular browsers you have going out at cable line, and you have a known abuser or a guest network that you really don't care about. You don't want it to interfere with the rest of your network. You could shove that off onto a slower WAN or one that has lower quality in some way. Well, so that's all the reasons you'd want to use Multi WAN. Now, when you're looking for an additional provider to use Multi WAN with, there are some really important considerations that you want to take into account. The first is the different connection types. You wouldn't want all of your WANs to be the same connection type in most cases, if you can help it. Most of these are kind of optional, but they're nice to haves. They give you a chance to be more robust. There's not perfect because every location is going to be different. Your provider layouts are going to be different. Different municipalities might run cables in different ways. But when you have some diversity in your connections, it can really help your overall chances of redundancy. So, I mean, say if you had two different cable lines, if the cable provider goes out, you'd still be down. Even there might be a chance where it might only take out one line, but it's still a pretty good chance that if they go down, they're both going down. Whereas if you have cable going one way and DSL going another, you have a better chance of still being up. So different cable paths can help with that too. So if cable goes out one side of the building, phone goes out the other side of the building, odds are if somebody slams into a pole, they're not going to take them both down. Or if somebody backhoes through one of the cables, it's not going to take them both out. Just depends on your paths. Again, all this varies depending on your location, but it increases your chances of staying up. You want to make sure you use different ISPs if you can, just because if the ISP has an upstream peering problem, even if it's nothing to do with your circuits, you could still be down just because the entire ISP's got an upstream peering issue. So if you have multiple providers, that helps sidestep that a bit. But you also want to be aware if you have two different providers and they're the same type in the same area, sometimes you got to be wary because they might be sharing equipment. So if you have DSL from your phone company and then you have DSL through a reseller that really just uses the phone company's infrastructure, in terms of redundancy, you're not that much better off than if you're using two of the same exact one. Sure, at some point they split and they go out different infrastructure, but there's still a shared segment of infrastructure where there could be a problem. So if you do have to use two different ISPs, you do have to have different subnets and gateways on each one. What that means is, say you ring up your cable company and you get two WANs and they give you just two different WANs in the same subnet, it's not going to work because you can only use one of those directly. Because pfSense at the OS level cannot see the same subnet and gateway on two different interfaces. It just doesn't work. So what you could do is take one of them, maybe stick some other cheapy router in between or turn the modem into a router. So it does NAT, just so that from the perspective of the firewall, you don't see two different subnets, you do see two different subnets. You don't see the same gateway on two different interfaces. You might also have some luck with calling up the ISP and saying, hey, I need one of these to be in a different subnet. They might, give you a different static IP block or something that might push you off into a different area of their network, and you might luck out and be okay there. Something to consider if you're in a data center type environment too, you might be able to use LACP to get some extra redundancy in terms of equipment redundancy. So it won't give you greater bandwidth on a WAN side, but it would give you some physical redundancy with maybe to multiple switches on the upside, which can help. So it's because of the way LACP works, especially on pfSense, it does L2 hashing, which means that pfSense is going to show a single MAC for that lag interface. The gateway is going to have a single MAC, and because it's one MAC to one MAC, it's only going to have one flow. It's going to utilize just one leg of that lag group. So it's a good thing for redundancy, but it's not going to get you greater bandwidth in this particular case. One word too about using 3G and 4G WANs as backup. It can work. It's kind of costly. You might want to disable gateway monitoring on those because the gateway monitoring is going to send a ping out every second or two or whatever, however you have it set. And when that happens, over time that adds up. A couple hundred meg a month, maybe more, maybe less, depending on your overhead, depending on how your provider counts traffic. So what you might need to do is, if that's your lowest tier, disable monitoring, and then, if you have to fall back to that, if it's up or down, really doesn't matter all that much. But just beware of the cost there. It can work, but your mileage may vary. So which one would you want to use between failover or load balancing? You can do one, the other, or both. Failover is going to prefer one WAN and fail to another when that one goes down. When with failover, when a WAN recovers, new connections are going to start going back to the preferred WAN, but they're not going to be cut off of the failover WAN. So say you prefer WAN fail to WAN 2. If your WAN goes down, your connections are going to start going out WAN 2. If somebody's got a long download going and WAN 1 comes back, that long download is not going to be interrupted and shoved back over to WAN because it would cut it off. It's going to continue to go through WAN 2 until it naturally stops, at which point any new connections will start going out the WAN. That way is the least disruptive. At the moment, we don't have a way to force a failback. That would involve, killing all the connections off the second tier or lower tier WAN, which isn't a very good thing to do. It's very disruptive, so we haven't tried to put much effort into locating a solution for that yet. Now with load balancing, as I mentioned a little bit ago, it performs connection-based load balancing. So browsers can effectively balance things out by opening multiple connections, although again, a single download in most cases is still going to just use one. The no single connection can fully utilize all circuits. But you can also run into trouble with things like HTTPS. Banks are really strict about this, or at least in our neck of the woods. If you balance HTTPS and your browser makes a connection out to your bank, it could actually make connections out both WANs going to that same session, and the server will say, hey, your IP address changed. I don't trust you anymore. I'm going to log you out. So banks do that. Some other places do that, which is good for security, but it's bad for load balancers. So there's two different ways you can get around that. The first is you can use HTTPS in a failover group. So you have like a prefer WAN type group, and then you would match your HTTPS traffic and put it in the failover group above the load balancing group, and then your HTTPS traffic would just prefer one WAN instead of being balanced, which is handy, but it may not be ideal because that kind of hits load balancing in the kneecaps a bit and slows it down because a lot more traffic is HTTPS these days, so it would effectively turn a good chunk of your traffic into failover instead of balancing. Our other option is using an option called sticky connections. What sticky does is it builds a user to gateway relationship. So a lot of people think, oh, it's just for a connection, but no, it's actually one internal IP address gets paired up with one outgoing gateway, and every connection that user makes is going to flow out of that one gateway until all their connections are closed. Once all their connections are closed, then it will have a chance the next time it goes to be balanced out a different WAN. So effectively what that does is it makes your users balance between the WANs instead of their connections balancing between the WANs, which depending on your users may be okay, it may be a little lopsided. So it is not as good as pure load balancing, but it is less problematic for protocols like HTTPS, and it's better than just strictly doing failover. So you can give it a try, see if it's good for you. You can kind of tweak that knowledge of the relationship. There is a source tracking timeout you can adjust, which I'll talk about that in a bit. What it does is it retains that user gateway relationship for a longer period of time. And so, if a user, especially like if they're going through their bank or doing their taxes, they may be stopped on a certain part of a form for a few minutes, and their browser may close those connections. And when it goes to open new ones, it may land on the other WAN and it still gets signed out. So you might need to increase the source tracking timeout a bit for it to be effective in your environment. And the only true thing that's going to get you both of these, as I sort of was touched on a little bit ago, is multi-link PPP or MLPPP. Unfortunately, support for that is very rare among providers. Sorry. You would have to have multiple DSL lines from the same provider, and all of those circuits would have to support multi-link PPP. And what what you do then is you just end up putting them into what is called a bundle. You edit the PPP connection and you just select all the interfaces there, and it actually signs into all of them at once using the same credentials, and it will bond them together with multi-link PPP, and it works at the DSL level basically to bond them into one larger circuit. So you actually do get the full aggregate bandwidth of everything. So if you had 3 different 3 meg DSL lines and you had multi-link PPP, one connection could actually get a 9 meg transfer. And as if a WAN fails, the connection still works, just with less throughput. So what you can end up doing is, you lose a WAN, everything works seamlessly, no need to do failover or anything fancy, nothing crazy, it just works, just at a slower speed. And then when the other WAN comes back up, your speed goes back up. Downside of that is it's harder to monitor to see if one of your circuits is down. You kind of have to comb through the logs or check the modem out, things like that. But if you have that available to you, it is a great option. It's just support for that is so rare around, at least in the U.S. It's very hard to get a hold of. But if you have it as an option, jump on it. All right, we're going to spend a little bit of time going over an example setup. Go all the way through here. As you can see from this diagram, in this example setup, it's just it's got 2 local networks, got a LAN, got a DMZ, and we have 2 WANs, 2 different ISPs. And this is the setup you can kind of see in the background over here on the right. So the 2 different internet providers, 2 different subnets on the WAN, and 2 different local subnets. In the example setup, I've got a client that I'll show you, and I've also got what is posing as a PBX in the rules and everything on the DMZ side. Now, for those of you who attended the DMZ hangout a couple of weeks ago or a couple of months ago, you'll notice that I've really hobbled the rules and everything on this just to keep it as a basic example. What I'm going to show you is not really a proper set of DMZ rules, but just kind of getting the point across for multiple local networks with different scenarios. All right, just the very high level view of what we're going to do here. First, we have to assign and configure the new interface. We're going to configure the gateways for it, add gateway groups, set up DNS, and then we actually have to use the gateway groups and rules to put everything into effect. There's a couple other things we need to check here and there, but that's the gist of it. You have to have the WAN, got to have the gateways, DNS, gateway groups, rules. Those are the high points. All right, so first things first. I've already got this assigned, but if you don't have your interface assigned yet, you would just have to come over here to interfaces and assign. Find your WAN and your available network ports, pick it from the list and click add. It'll show up as like opt2 in your list here. Then you just go up to interfaces and pick that new one, which in this case would be like opt2, and you just have to go in here, enable it, give it a good name. In my case, I called it WAN2. I've got static IP here, but just set it for whatever type your internet provider gave you, whether it's static or DHCP or PPPoE, whatever. Now your settings are going to vary based on your type. You'll see here I've just got my static IP address, my subnet mask, and I configured a gateway. For static, you probably won't have a gateway entry in there yet. You can click add a new gateway here, which brings up a nice modal to add a new gateway name and give it an address. Once you've got all that in there, save that entry and apply it, and then your WAN's good to go. You can give it a shout over here on status and gateways. Check it, make sure your gateway shows online. If it doesn't show online, you need to go through your usual WAN troubleshooting steps there. You need to make sure that you've got actually do have connectivity, make sure you got your IP address and gateway settings right, and so on. Move on to the gateway settings here. We're going to system and routing. As you can see here, I've got my 2 gateways in here. One thing you probably want to do is set a custom monitor IP address. You don't really want to monitor the gateway address directly in almost all cases because it's usually the gateway is your modem or it's maybe your next hop up at the ISP. That only tests your circuit. It doesn't test the quality of the connection all the way out to the internet. So a really good option is to use an anycasted address like the Google public DNS, the 8888 and 8844. Those addresses are anycasted, so no matter where you are in the world, you're going to get you're going to actually have a path to a network that's not too far from you. So it's very little chance that you can't reach that, and very little chance that if if you can reach that, odds are that your internet connection is good. If you can't, odds are it's not going to be usable. Even if your circuit's okay, your ISP may be having peering issues. You probably are. I mean, if you only had one WAN, it was obviously your default before. But if you do, if your WAN 2 or whatever that you're adding is a higher quality than your WAN, and you want you want your firewall to send this traffic out this new circuit, you will want to set that as your default. You can go ahead and just check the default box on the gateway, which is right here. If you want it to be the default. In this case, I want to keep WAN as my default, so I'm not going to change that. The default gateway is where traffic from the firewall itself is going to leave, and also any traffic that doesn't match a rule with a gateway is going to flow out of your default gateway. And also UDP replies from daemons bound to any or all are going to take that default route. I'll touch on that a little bit later, but that can trip up some services on the firewall for multi WAN if you have, depending on how you have your bindings right. We do have the default gateway switching I mentioned. That's I'll get into it a little bit more later, but it's just under System Advanced Miscellaneous tab. So if you have two gateways like I do, if you enable default gateway switching, if your default goes down, it's going to flip the default for the firewall over to your second WAN, and then when the first one comes back, your default gateway will immediately go back to your preferred WAN. There are some advanced options you can set here on gateways as well. First up is the weight we talked about, where you can set your basically a bandwidth ratio if you want. Depending on how you have load balancing, you may or may not actually want to use those. You may not care, or you may want to set a relationship. It's like like I mentioned before, like a 1-to-2 ratio, or 5-to-10, or 3-to-10, or whatever the bandwidths are you have to work with, or reduce the fraction of them, get close to what you can. The rest of these advanced options, most of the time you don't really have to tweak any of them, but in certain special cases you might need to, like if your ISP, we had one case where somebody's, some piece of equipment wouldn't respond to the particular payload used by dpinger, so we added an option to let you customize that. Latency thresholds and packet loss thresholds, those really depend on your circuit. If you have a DSL circuit, you might notice that it works better even at higher latency. If you have a cable circuit, you might notice that it works better even at higher packet losses. So you might increase those because your circuit may be usable. It's just your provider is deprioritizing or dropping the ICMP responses when it's busy. So you wouldn't necessarily have to flag those as a failure until they become unusable. Now, actually defining the levels that become unusable, that's a bit trickier. You kind of have to wait and see how your circuit reacts. If you load it up really high with transfers and it fails when things are still moving pretty good, increase those thresholds and you might find that it still works. And then when you finally hit a level that breaks, you might want to back it off so you don't keep sending traffic out of WAN that isn't very good. The rest of the options there are kind of covered on the page. Most people are never going to have to touch them, but you can if you want to. There's another option down here at the bottom that's new. There are some providers that really have broken network designs where they give you a gateway that's outside of your subnet, which is really quirky and it's not ideal, but if you have to do that, you can add a gateway this way. You just have to check that box when you add the gateway, and it will allow that gateway to exist outside of the interface subnet, and we'll use a different set of commands to set up the gateway. All right, moving back over here to system and routing. and gateway groups, this is where you will set up your different load balancing and failover scenarios. The groups themselves don't actually do anything to control traffic. They define the scenarios you want to use, but to actually implement those, they have to be used in a rule, they have to be used with a compatible daemon, they actually have to be put to use somewhere. So just defining the groups is not going to hurt anything. Just defining the groups is not going to actually put anything into effect. So you really just need to define them here first, and then once they're defined, you have to actually put them in place. So the different tiers of the gateways define their behavior. If you have two gateways on the same tier, they will load balance. If you have two gateways on the same tier, the tier with the lower number is going to be preferred. So tier 1 is the preferred tier. If all the gateways on tier 1 are down, it will fail over to tier 2. Show you how that looks here. And you can pick anything from tier 1 to tier 5. And you can have all sorts of different scenarios in place here. You could have two gateways that fail over, like say you had 5 WANs. You could have 2 of them load balance for tier 1, 2 of them load balance for tier 2, and then one is just on its own tier at tier 3 to be used if the first 2 groups are down. There's just one of many different scenarios you can do. The trigger level here can be a little tricky. Most people are fine with member down. If you find that's not sensitive enough, you can try to use either the packet loss or latency or the packet loss or high latency trigger. And when you do, the gateway will, the failover or whatever action you're defining here will take effect when it reaches the alert status instead of the actual down status that it does with member down. And then there's a description here for your reference. Now what I like to do, and this is optional, but it's a good starting point. I like to have 3 gateway groups to start with. First is a load balancing group where it has all your gateways on one tier. And then I have a group that prefers each WAN that I have available. So in this case, I've got 2 WANs, so I have 2 additional ones. I've got prefer WAN, which has WAN, the main WAN, WAN 1 on tier 1, WAN 2's gateway on tier 2. And then I have a prefer WAN 2 gateway group that does the opposite. It has the WAN 2 gateway on tier 1 and the WAN gateway on tier 2. And as you can see in here, it looks similar. You just have that particular gateway. You just have it picked on another tier. Now having all of these defined gives you a lot more flexibility. So you can prefer to have traffic go one way or the other or be balanced depending on your needs. As I mentioned before, you might have some traffic you always want to go out WAN or always out WAN 2. You may have a server that doesn't take kindly to load balancing, especially a PBX wouldn't want to be load balanced. So having these other scenarios gives you that flexibility, and just defining them doesn't hurt anything. So you don't really have to be worried about having them there if you're not going to use them right away. Although if you think you're never going to use one, you can leave it out. Just if and when you decide you will need it, you can always go back and add it later. Now DNS with failover is a little bit trickier now because you have the option of using either the DNS forwarder or the DNS resolver. And this is true on 2.2 as well as 2.3. The DNS resolver itself has 2 different modes. One is forwarding mode and the other is non-forwarding mode. The current default for new installations is using the DNS resolver in non-forwarding mode, which kind of doesn't really get along very well with Multi WAN, but we can make it work that way. And we'll talk about the other scenario first, and that's if you're using either the DNS resolver in forwarding mode or if you are using the DNS forwarder. And both of those will actually, when a DNS query happens that uses the DNS forwarder or the resolver in forwarding mode, the query comes to the firewall. The firewall will query the DNS servers you've got under system in general. And how you would, before we get to that point though, how you would tell if you're using forwarding mode or not, under services and DNS resolver, if the DNS resolver is enabled and you have DNS query forwarding checked, then you are using the DNS resolver in forwarding mode. If the DNS resolver is not enabled, check under DNS forwarder. If the DNS forwarder is enabled, then you're using the DNS forwarder. In either of those cases, you need to make sure that your DNS servers are set up here under System and General Setup. And as you can see here, I've got 8888 going out my WAN and 8844 going out WAN 2. Now you might have noticed that I was using those for my monitor IPs as well, and there's an important factor that you have to consider here. If you used 8888 for your monitor IP for WAN 1, when you come to configure your DNS, 888 has to also use WAN 1 for your gateway here. Why that is because it sets up a static route when you do either of these functions that will send that IP address out that specific WAN. So you don't want to try to give it conflicting information trying to send either, the same one out two different WANs is not going to work. It'll take whichever one was in first. So be mindful of that when you're setting up your monitor IP addresses. If you use those same addresses for DNS servers, make sure you choose the same WANs that you chose before for these. So I've got 888 going out WAN, 8844 going out WAN 2. As I mentioned before, this particular firewall example I've got is using non-forwarding mode. So this isn't as important, but it would be used by the firewall itself if needed. So the DNS forwarder will query all servers at once, so it will use whichever response is fastest. So that can be a little bit better for a multi-WAN scenario. It doesn't have to wait for something to time out. The behavior with unbound and forwarding mode, I'd have to confirm what that is. I'm not sure if it has that same behavior or not, but you just have to tinker with it and see what's going on there. But it does depend on those upstream DNS servers. And because the quality of those forwarding servers varies a bit, you might find if you're using the DNS resolver, you may or may not be able to use DNSSEC in those particular cases. If your forwarders aren't high enough quality, if they don't support it, they monkey with results and so on. So if DNSSEC is important to you, which in this case, in this example, it is, then that's not going to be an option. So we're going to have to use the DNS resolver in non-forwarding mode, which to do that, all of those queries are going to have to go out the default gateway of the firewall. Because when the DNS resolver is in non-forwarding mode, it has to contact the root DNS servers and authoritative DNS servers directly. So it's going to be contacting addresses you can't reliably predict. And so you can't load balance that traffic out from the firewall itself. You can't do, so we have to do default gateway switching. So it will move our default gateway over to another WAN when the first one goes down, and then so your DNS will continue to function. Now another option I didn't mention here, if your clients will contact the DNS servers directly, like say you hand 8888 and 8844 directly to your users, you don't have to worry about your configuration of DNS on the firewall because you can load balance or failover those user connections going out directly. That you don't have as much control over DNS, it'll be a little bit slower because you don't have the benefits of using the cache. But if you're worried about how the DNS resolver on the firewall is going to work, that's another viable option. All right, so as I mentioned, we made these groups, but they didn't do anything yet. So now we have to actually put them into place. So I'm going to go up here to the firewall menu and choose Rules. I'm going to look at my LAN tab. Now, a couple of important things here. To use these groups, we have to choose them as a gateway on the rule. So I'm going to come down here to my default LAN rule, edit this guy, scroll down into the advanced options. By default, this will be hidden. You click that display advanced, scroll all the way down here, and then there's our gateway option down here toward the bottom. So because I want these guys to load balance, I'm going to do load balancing here, call it load balancing group, and then save. Now, any connection that hits this rule is going to be load balanced, which includes anything that might be trying to go out to a VPN or over to my DMZ, which I don't want. So what I had to do in this case is negate that policy route by using an extra rule above it. And for the people on the LAN here, I only negated the DMZ. So what happens here is the traffic will come. If it's coming from the LAN to the DMZ, it will leave without a gateway set. So with that gateway not being set, that will follow the firewall's default routing table, which will hand it straight over to the DMZ. And the same would go for, like over here on the DMZ, I have all private networks in an alias here, this RFC 1918 alias. And so if it's going from the DMZ out to any private network, it will go without a gateway set. And so it will just flow using the routing table. So it will work for VPNs, it will work for my other local interfaces or anything that's privately numbered. And any other traffic is going to hit this lower rule that has this prefer WAN 2 gateway. So for my DMZ, for my servers, they're going to prefer WAN 2 and they'll fail back over to WAN 1 if that goes down. So one thing you only want to make sure using these gateways on internal interfaces, you never want to use them on WANs. The WAN rules will be handled automatically. The reply to keyword I mentioned earlier, that all happens behind the scenes. You don't have to add gateways on WAN rules you don't want to. Now, whether or not you use gateways on VPN rules like IPsec and OpenVPN, that's up to your particular scenario. If you have users coming into your VPN that will eventually go back out to the internet, you may treat it like I did that, the LAN of the DMZ, pass your local traffic that they're allowed to get to, and then on your pass to any rule, add your load balancing or failover group on your VPN rules. Now, another important thing to note, you cannot use policy routing on traffic that's outbound from the firewall itself. I've kind of mentioned that a couple of times, but it's important to reiterate because a lot of people still come back and say, well, can I load balance Squid? No, you can't load balance that traffic leaving from the firewall. And the only way you can get failover is with default gateway switching. So you can do failover with Squid by doing default gateway switching. So, you set your default WAN goes down, it'll flip over to your other WAN, and then your, proxy traffic, whatever, is gonna continue to go out okay. You just can't load balance. And you can't have like multiple different scenarios coming from the firewall itself, like some traffic out WAN 1, some traffic out WAN 2, that won't work. Okay, so now we've used the groups on rules. Let's check some services on the firewall, show you how that works. I don't have any dynamic DNS entries on here, but when you do, it's really easy. You just pick your provider, and then for the interface to monitor, you choose your failover group. You have to use a failover group. Every gateway in that group that you use has to be on a separate tier because the behavior for load balancing a service is undefined. Every time it started, it would pick a random address, and you really don't want that. So you have to use a failover group. So the important areas to note that support this are dynamic DNS, OpenVPN, and IPsec. In any of those areas, you can choose a gateway group for an interface. Now, whether or not you want to is another question. Cover a couple of different scenarios here. About a year ago, or maybe it was longer ago, I did an OpenVPN hangout with advanced OpenVPN. And I covered a lot of multi-WAN scenarios there, a lot of things you might want to do. So all of that really still applies, so you can go back and watch that. You really do not want to use the gateway group for an interface of an OpenVPN server. You can, but it's not ideal. There are a lot better options out there. So you could have the same server active on all WANs at once by binding that OpenVPN server to localhost, and then you do port forwards on each WAN that point to that service on localhost. And then when you use the export package, and there's an option in the host resolution to choose one of the automatic multi-WAN types that will add a line for every port forward it finds to the configuration for the users. So it's a really good way to get redundancy without a lot of extra effort there. Now that works for remote access. That also works for site-to-sites where you could have a site-to-site that fails over. That way your remote users could, you could just add a second remote line into your configuration of the site-to-site VPN that points it to your other WAN address. So that works too. Another thing you could do is you could copy that server, all of the settings except for the tunnel network. The tunnel network has to be different because it's two different instances. Maybe run it on a different port. And then you could connect to both of those independently, one on each WAN if you want, but that's kind of up to you. If you have a site-to-site VPN, you could have tunnels up all the time on every WAN and run a routing protocol like OSPF to have it choose the paths. That's kind of desirable for a site-to-site scenario because it's a lot faster at detecting a failover or recovering from a failover, seconds instead of minutes. So that's a good option. It's a lot more complicated to get running, but once you've got it running, it's pretty robust. And lastly, you could use a gateway group as an interface there if you want to. The downside to that is Your users still have to know about both WANs, so you still have to have both the remote lines on your end users, but it's only going to be active on one WAN at a time. So it's going to be active on WAN. WAN goes down, it's going to be active on WAN 2, but it's not going to be active on WAN 2 until it goes down on WAN 1. So your users are going to be, if they get disconnected from WAN, they're going to try WAN 2. It's not going to be there yet, and it's going to keep bouncing back and forth. It may take them a few minutes to lock on to that second service being active on WAN 2. So it works, but it's not ideal. It's not as robust as using one of the other methods. Now, if you're talking OpenVPN clients, it's a different story. That works just fine to use the gateway group as the interface for the outbound traffic. It's pretty slick. It works pretty well. You could also use, as I mentioned, the OSPF method, or you could do multiple remote lines. If you do multiple remote lines on a client that's got multi WAN, you might want to consider sending each one of those remotes out a different WAN, so you have multiple addresses on the server end of things, but it can get kind of convoluted, and it's not a perfect scenario either because it kind of breaks some of your failover. So for clients, I would stick with using the group as the interface or the OSPF method if you can. All right, IPsec for site-to-site, it works fine with using a gateway group for the interface, but you have to combine that with a dynamic DNS entry set for the same group. Your far side peer is going to use that dynamic DNS entry as its peer address, and then if your WAN fails, DNS is going to get updated to point you to WAN 2. IPsec is going to start binding to WAN 2, and the remote end will pick up on the address change because the DNS changed, and then it will lock onto the other WAN there. Now, all in all, between DNS and everything, that could take a minute or two to happen, especially depending on your TTLs, but there's no real better way to do that for IPsec that isn't 9 kinds of crazy. For mobile clients, a similar story. You can use the gateway group and dynamic DNS, but you have to combine that with default gateway switching because otherwise the reply traffic may take the wrong path back out. Just the way that the replies get sourced is not ideal. Something else you have to consider also is your outbound NAT. Most people will not have to worry about this because their NAT is going to be on automatic. So it's just under firewall and NAT on the outbound tab. As you can see here, I'm on automatic outbound NAT. Because I have my WAN gateway set right, I have a set of rules for WAN and a set of rules for WAN 2. If you were on manual outbound NAT, you just need to copy your rules from so that you have all of your rules from WAN replicated over to WAN 2 so they're going out in similar scenarios, whatever you've got. If you are on automatic, but it's only showing your rules for one of your WANs, odds are it's a static WAN. Maybe you didn't select that gateway right under interfaces in WAN 2. So you check your gateway configuration and make sure it's right. If you were on manual, just got to clone those rules over, you'll be fine. If you're on automatic, you shouldn't have to worry about it, but it's good to come in here and double check and make sure you've got the rules showing up. Now, just to reiterate a concept I've mentioned a couple of times, the firewall rules using gateway groups, that is what performs policy routing and controls where the traffic will go. The NAT rules here do not control where the traffic goes. The NAT rules only control what happens to the traffic as it leaves. So you just have your traffic hits a rule, wants to go out WAN 2, the firewall will try to send it out WAN 2, and then the NAT will take effect to translate that as it leaves WAN 2. So it's at the end of the process there. Now talking about inbound NAT, so one-to-one NAT, which I don't have anything on, or port forwards. Similar concept, you have to have a rule for each WAN. So if you want the port forwards to be active on both WANs, you have to have port forwards on both WANs, which may, by extension, also mean you may need to have the same number of IP addresses or virtual IPs on both WANs, and have your own sort of documentation about what goes where. Like say you have a /28 on each WAN, you may have to have a similar set of VIPs for both WANs, and then you could have similar port forwards one-to-one NAT, whatever, for both WANs. But the main idea here is if you've got a rule for WAN and you want it to work on both, you have to have the rule on WAN 2 as well. In most cases, that's as easy as copying the rule, changing the interface to WAN 2, changing your destination address, and then that's it. So you can see in this case, I've got the WAN 2, I've got my PBX ports, and I also have HTTP, the web port open. Now these are going to be active all the time. You don't need to have any concern here for failover. Both of these are going to be able to be used at both time or at all the times. So if I go back here and look at my interfaces, I'm 198.51.100.3 and 2030.113.3. And I'm trying to access the web server here. You can see, just make sure it's a live connection. I'm showing you the time is changing. I'm accessing this on 198.51.100.3, hitting my port forward. Same story over here on my WAN 2, 203.0.113.3, and it's updating. So I'm actually able to hit that same web server from both WANs simultaneously. Same with other things. If you want that to actually have a failover component from a client point of view, combine that with dynamic DNS. Put a dynamic DNS entry on, use whatever failover group you want. The DNS will fail over. The clients will eventually get that answer. And you can be fancier with that if you've got some tighter control over your DNS. You could have them both active with round robin. You could have whatever kind of scenario you want. That's all up to you. But in terms of the firewall, as long as you've got your gateway set right, you got your NAT rules set right, it's going to have those active all the time. You can choose however you want to receive that traffic with DNS. And same thing with OnetoOne NAT. You may have a scenario where you want that active on both WANs as well. Or if you there's another scenario, didn't really mention it here, but if you have OnetoOne NAT, like say you've got a block of IPs on one WAN, but you only have one address on another, you could, with rules, lock it down to where they can only go out the WAN where they've got an external address. Whereas if they fail over to the other WAN, they may be able to go outbound but not inbound, which may be less desirable. So that's totally up to you and however you want to receive that traffic or send it out. All right, talk about a little more fine tuning you can do before we get into the testing and everything. Fine tuning you can do is under System Advanced on the Miscellaneous tab. Now, I've hinted at a few of these things already. I'll talk a little bit more about them here. First up is the sticky connections and the source tracking timeout. As I mentioned, they do a user to gateway relationship, and it can help with HTTPS and other services. And that relationship will last as long as there are states from the source IP address flowing out anywhere. It's as long as the states are passing through, PF will maintain that source tracking and send them all out to the same gateway. So I might go out and use WAN 1, and then all my connections are going to keep going out WAN 1 until all my connections close. Somebody else may end up going out WAN 2. And so that user to gateway relationship is maintained as long as there are active connections. If that's not long enough, you can bump this source tracking timeout up to where it's defined in seconds. How high you want to make that is completely up to you, but you might notice that you need to make it very high in some cases, depending on what your users are doing. Just as an example, I know I've mentioned a couple of times, like doing your taxes. You might sit on an online tax form while you type stuff in or do calculations locally. You could be there 15-20 minutes or more, and who knows what your connection is doing in that time. Now, a lot of sites will time you out in that, so you may not have to worry about going too high, but in some cases I could see you needing to set this as high as 10-15 minutes, but depending on how browsers work and everything else, in reality is probably significantly less than that. Again, all depends on your environment though. Right underneath there is default gateway switching, which you can see in this particular case I have enabled. And that works well now with all known WAN types, so you shouldn't have any trouble with that. Your only downside is going to be if you have local gateways that are in that list. What you might end up having to do is sort of rearrange them manually one way or another by deleting, adding. You can't reorder the gateways in the GUI yet, but you might find that you need to get your external gateways up at the top of the list one way or another. But it's pretty safe these days to activate that, and there are more people that can use it successfully than there are that will have problems now. So it's a pretty safe option to enable if you need it. Now the next one here, these options have been kind of confusingly worded over the years, and we've tried to clean that up and make it a lot more obvious here. So really be sure you're reading this and understanding it before you activate it. State killing on gateway failure, what that will do, if this box is checked, it will flush all states when a gateway goes down. And when it says all states, it means every state. So as your connections flow out, the firewall keeps knowledge of that connection in a state. And so if your WAN goes down, some of those connections may still be up trying to go out of that WAN. So especially for long-lived UDP connections like from a PBX registration, whatever, that may still try to go out that WAN for an indefinite, effectively, a period of time. So you might activate this feature, and what that will do when it's active, if a WAN goes down, it will kill all of those connections, and then everything will try to reestablish on the other WAN when the clients reconnect. And it can be very disruptive, which is why it's off by default. The problem with it mostly is if you have everything on your WAN's fine. If you're only doing failover, everything's going out WAN. If your WAN 2 gateway goes down, it will still kill all your connections on the WAN because it says, oh, the gateway failed, I have to kill all these things. Or if you have a gateway that's down and staying down, and it can also affect your connectivity to the firewall that way. So it's not a good thing to have active in some cases, but it can help with others. So again, personal choice for your environment, whether or not you want that. If you have VoIP devices, like PBX phones, whatever, odds are you are going to want that, but it is completely optional. It's up to you. Now the other option here is to skip rules when a gateway goes down. What that lets you do is it gives you some more flexibility with blocking people or controlling their behavior. So I mentioned before the scenario where you might want to shunt traffic from somebody who's like an abuser off to a lesser quality WAN. If you want to tie them to only that WAN and no other WAN, what you would do is you would activate this option and change the rules a little bit. With the option unset, just the normal default behavior, if a gateway goes down, the rule is just treated as if it has no gateway. So it will start flowing through the default WAN when the chosen WAN is down. Which that's good because it will keep the traffic flowing, but in some cases you don't want that. So if you have this option checked, it will omit the rule entirely when the gateway is down instead of just omitting the gateway. So with the rule omitted, it will fall through and hit whatever's below it. So you'd have two rules that match traffic from the same user. The top one that passes with that gateway, the bottom one would block them or reject them rather, would be a better option. And so with this option checked, that first rule would be omitted, and then they would hit the reject rule and they would not be able to get out at all. So that's a good way you can force somebody to use one WAN and not have any connectivity at all if that WAN goes down. So there are some use cases out there for that, more common than you might think. So just keep that option in your pocket if you need it. It's there. All right. So when you're doing some testing, before you do anything else, like we did earlier, you want to check your gateway status. Make sure it's online. If it's offline, you got to check your WAN out, make sure your settings are right. You might try a different monitor address. Do whatever you got to do to get to that gateway online initially. Your groups should show a similar status. Load balancing, you can see both mine on tier 1 are up. Prefer WAN shows my tier 1 is up, tier 2 is up. Prefer WAN 2, tier 1 is up, tier 2 is up. As you fail a WAN, those will obviously change. So you want to make sure all those are working. If it's down, you might need to, like I said, try a different monitor address, make sure your pings are going out, make sure your modem's all right. You might even have to go so far as to test the WAN settings, like with a laptop on the modem, power cycle the modem, that kind of stuff. Now, when you go to test load balancing out, you need to make sure you use a fresh browser every time you try to do it, because a browser is going to hold a connection open indefinitely in most cases, or at least for longer than you want. So when you try to, like what is my IP.com or a speed test or whatever, that's going to show you whatever the browser is connected through. If you refresh that page, it's not necessarily going to break that connection and start a new one. So if you close the browser, reopen, it will get a fresh connection. You can try it. Even better is like I've got going here. I'm just running curl at the command line, hitting an IP test, and you can see it's hitting the load balance rule, and the server's seeing it come from 2 different addresses. Do a little for loop, do it 10 times in a row, and it balances quite evenly. Now, if you change your weights and ratios, you'll see it change, but the proportions will stick to your weights. And these are all connection based again, so you need to make sure it's opening a fresh connection. Either use multiple browsers, close the browser, reopen it, use curl, something like I've done here. When you are testing, you want to test different types of WAN failures. Each of these will lead to the WAN going down, but the behavior can be different. Like if you unplug the interface, unplug the cable straight from pfSense, pfSense will see the interface goes down, and it will act in a different manner than it would is if the interface stays up but your upstream goes down. So one scenario you want to try and unplug from the firewall. The next scenario you might turn off your modem. The next scenario you might unplug your phone or coax cable from your modem, and so the firewall still gets to the modem, just no further. So any different types of scenarios you can come up with to test. Try them all, make sure they all work. Now if we look at our gateway status, I'm going to come over here and I'm going to cut this WAN off. And as you can see, as I'm refreshing this, it's seeing the WAN get more and more lossy, and then it just flipped over to being offline, and it's showing it's down. So if I come back over here and try my test again, it took WAN 2 completely out of the balancing. Every connection went out WAN 1, which is what I expected. And you can see the loss is still kind of counting up there. Now if I bring this WAN back up, this is where dpinger treats things a bit differently than apinger did, and it's a good change. It doesn't immediately assume because it received a ping back that the WAN is up. It keeps that average going, and then as the WAN quality is confirmed good over time, it will bring it back up. See, the average is still going, now the loss is going down because it's recovering. And eventually, when it gets back under the threshold, it will be treated as if it's back up. Now, it's a little slower to recover that way, but you're more assured that the WAN is going to be usable when it does so. If it jumped right on it when it came back up, it could be flapping. It could still be dodgy. You want it to be careful. And now we're back to 10% loss. So I show you back here on the widget, it'll refresh itself automatically. And now it's back to no loss. And if I come back here, rerun my test, you can see I'm balancing again. So, I mean, that's about it. I don't know if you guys have any questions about anything. I didn't see anything come through on the chat, but let's see. If you're going to have a question for me, go ahead and let me know that you've got a question coming. And, you know, kind of type something, just sort of, whether it's a dot or something, just so I know you've got a question coming. And then I will know to wait for you. So we've got pretty good handle on doing you should have a pretty good handle on doing multi-WAN now. Mail notifications can still kind of cause, it really depends on what you're doing. If it tries to suppress notifications if the same one tries to go out multiple times, but if there are several notifications that are slightly different in a row. They can kind of repeat. That's something we still haven't got a good clean fix for. That's something we're hoping to address that in 2.4. Completely, I think we're completely redesigning the notifications if I remember right, but I have to double check the roadmap. I haven't seen it make the GUI non-responsive, but that's if there's a bug or something yet, open it up on the forum, we'll talk about it a bit, but it could just be that PHP is getting hung up trying to reach something that's not there, but that's not something I've seen yet in my testing. All right, anything else? Anybody else? How would you fail over between an LTE router with onboard authentication and a DSL router in bridge mode? Whatever you would normally have to do to get connectivity on both of those. I mean, they'd each be on separate interfaces. As long as they're both things that pfSense can talk to and get out, it's just like I showed you. Treat them just like separate interfaces, and off they go. See, turn off gateway monitoring on non-responsive interface. Yeah, if you have a gateway that you know will, like, say, block ICMP and it will never return anything, you can choose to, in the gateway options, to disable gateway monitoring for that interface. When you do so, it will always be treated as up. Yeah, I mean, you could. It's not a very good option to do that if you can help it, though. IPv6 failover with netting doesn't work 100% of sites. Well, some do. I have not seen that. I'm using IPv6 failover on my home. I've got 2 different WANs. I've got 2 tunnels, one going out each WAN, and I have NPT on the secondary WAN, and I do failover, and I haven't had any trouble at all with mine. But there could be a setup issue you've got there, but that's not something we can talk about right now. I didn't cover IPv6 on this one because I was trying to keep it short, and we're already a little bit over. Right. Anything else? Anybody? Going once, going twice. All right. Well, if there's nothing else, I guess that'll wrap it up for the month. By the time we reconvene in a month from now, 2.3 should be out and everybody should be using it, and everything should be great. So just keep an eye on the blog. If you have any ideas for Hangout topics that we haven't covered or haven't covered in a while, you think could be recovered, just drop us a line, either on the forum, blog post, comments, Reddit, wherever you want to send us a comment. Just let us know. And it's been a pleasure with you guys, talking to you guys this month, and we'll see you back here in a month.